Hello everyone, in this video I'm going to discuss the example for limits and also the asymptote. So given we have the function, so 2x squared plus the 2 over x squared minus 4. So rewrite the function. We have the first function as given. The second function we have 2x squared plus with the 2 over, we have x minus 2, x plus with the 2. So find the vertical and the horizontal asymptote of the graph and then sketch the graph. So step number 1 will be the domain for the function. If it refers to the situation, the domain we have negative infinity until negative 2 union negative 2 until 2 union 2 until infinity. So we have two different parts we have to discuss. The first one is x equals to negative 2 and the second one is x is equals to 2. Second step, find the intercept. So for this part, the x-intercept when y is equals to 0. So when y equals to 0, if we substitute the situation and we notice that we have 0 equals to 2x squared plus with the 2. Then we have negative 2x squared equals to 2. X squared is equals to negative 1. So no solution for the x when y equals to 0. In order to find the y-intercept, x must be equals to 0. So if we substitute 0 for x, and we notice that the y will be equals to 2 over negative 4, y is equals to negative 1 over 2. So we have the point 0, negative 1 over 2. Next, we are going to find the vertical asymptote. Limit when x approaching negative 2 from the left. Limit when x approaching negative 2 from the right. Substitute the function. So in here we have 2x squared plus with the 2 over, we have x minus 2, x plus 2. 2x squared plus with the 2 over x minus 2, x plus with the 2. So if we focus on the situation, in here we have the value negative 2. On the left, we have negative 2.0001. On the right, we have negative 1.999 and 9. So in this part, we have two situations, or we can say two methods. Number one is substitute and then determine whether the situation is positive or negative. Second one, we may make use of the calculator in order to calculate the value. So number one, if we substitute the negative 2.0001 on this part, for sure we will have the positive value. Next, if we substitute on this part, for sure we will have a negative value. Next, if we substitute on this part, the negative 2.0001, for sure we will have a negative value. So as a conclusion, it is positive infinity. Next, we have to substitute negative 1.999. So if we substitute on this part, for sure we will have a positive value. If we substitute on this part, for sure we will have a negative value. If we substitute on this part, and we will have a positive value. So in conclusion, we have the negative infinity. So on the left, the limit increasing without bound or without limit. On the right, the limit decreasing without bound or without limit. So that is the first vertical asymptote where we have x is equals to negative 2. Continue. Limit when x approaching 2 from the left. Limit when x approaching 2 from the right. So can you substitute the function? So here we have 2x squared plus with the 2 over x minus 2, x plus 2. 2x squared plus with the 2 over, we have x minus 2, x plus 2. So kindly focus on the situation. So now here, let's say we have the value 2. On the left, we have 1.9999. On the right, we have 2.0001. If we substitute the 1.999 into this part, and for sure we will have a positive value. For this part, we will have a negative value. For this part, we will have a positive value. So when x approaching 2 from the left from the function, and we will have the negative infinity. So if let's say x approaching 2 from the right, we are going to substitute 2.0001. For this part, for sure we will have a positive value. If for this part, we will have a positive value as well. Same goes to this part. So the limit will be increasing without bound. So another vertical asymptote. As a conclusion, the vertical asymptote are x is equals to negative 2, x is equals to 2. So next, we are going to find the horizontal asymptote. So number 4. Limit when x approaching negative infinity. Limit when x approaching positive infinity. So for this part, we have two functions. So kindly make use of this function, where we have 2x squared plus with the 2 over, we have x squared minus 4. Same goes on the right, we have 2x squared plus with the 2 over x squared minus 4. So for this case, if we substitute the situation, and we will have infinity over infinity. So when we have the IDF, the suggested strategy would be dividing the numerator and the denominator for the highest power of x for the denominator. So meaning that kindly refers to the denominator, we have the x squared. That is the highest power. So factor out the x squared. So here we have x squared bracket. So we have 2 plus with the 2 over x squared. Over, we have the x squared bracket 1 minus 4 over x squared. If we simplify, limit when x approaching negative infinity, we have 2 plus with 2 over x squared over 1 minus 4 over x squared. If we substitute 2 over infinity, for sure we will have 0. Same goes to the 4 over infinity, we will have 0 as well. So left behind we have 2 over 1. So the value of y will be approaching 2 as the x approaching negative infinity. Next, focus on the right hand side. Limit when x approaching positive infinity. So here we will have IDF as well. Next, what we have to do is to factor out the x squared. So we have 2 plus with 2 over x squared. Over, we have the x squared. We have 1 minus 4 over x squared. So finally, limit when x approaching positive infinity. We have the situation 2 plus with the 2 over x squared over 1 minus 4 over x squared. If we substitute, and we will have the value of y approaching 2 as well as the x approaching positive infinity. So as a conclusion, horizontal asymptote is y is equals to 2. So kindly refers to the question. The question asks us to find the vertical and horizontal asymptote for the function fx. So number 1, we have the vertical asymptote, x is equals to negative 2 and x is equals to 2. Number 2, we have the horizontal asymptote, y is equals to 2. Next, the question asks us to sketch the graph. So first, kindly refers to the domain. We have the negative 2 and 2. So let's say here we have 1 and 2. Here also we have negative 1, negative 2. So kindly plot the asymptote. Continue. Next, we have the second step, intercept. There is no x-intercept, so ignore. But we have the y-intercept, where we have 0, negative 1 over 2. So 0 is over here, negative 1 over 2. Let's say the situation around here. So we have the coordinate 0, negative 1 over 2. Next, continue. Kindly refers to number 3. Limit when x approaching negative 2. From the left, we have positive infinity. So 2 from the left is on here. Infinity. So meaning that we have this part. Continue. Limit when x approaching negative 2 from the right. So here we have negative infinity. So the situation around here. Continue. Limit when x approaching 2 from the left. We have the conclusion, negative infinity. So decreasing without limits. Next, when x approaching 2 from the right, we have increasing. So we have the vertical asymptote stated, x equals to negative 2 and x is equals to 2. Theta. Next, move on with the negative infinity. So if it refers to number 4, notice that we have when x approaching negative infinity, the value of 2 approaching 2. So in here, they mentions that when they're moving towards the left, and we will have the value 2. So let's say here we have 1, here we have 2. So we have another asymptote, where we have y is equals to 2. So as x approaching negative infinity, we have two situations, either above the 2 or below the 2. When x approaching positive infinity, the value of y also approaching 2. So we have two situations. So kindly make use of the calculator. So you may key in the calculator for the function 2x squared plus 2 over the x squared minus 4. Let's say negative infinity. We substitute a value of x, for example, negative 50. So if we substitute negative 50, notice that the calculator shows us we have 2 point something. So meaning that above the 2. So from here, we can ignore the value less than 2. So our answer will be above the 2. Next, if we calculate the situation as x approaching positive infinity, for example, if we substitute 50. And we notice that the calculator also shows us a value more than 2. So meaning that our answer will be more than 2. So finally, our graph will be something like this. Start from this part when x is equal to negative 2. Next, we have another situation. Here will be the bottom part. And then finally, so that is the graph for this situation. So do remember, stated the function, we have fx is equals to 2x squared plus theta 2 over x squared minus 4. So write down the interception, the asymptote, and the point as well. If you are new here, kindly consider subscribing to this channel and share this video to your friend. Thank you so much for watching this video. Bye.